So today we are going to be talking about how Kubernetes actually helps in the production chain. What is the role of Kubernetes in the production chain, and the various questions that you are going to get concerning Kubernetes, possible questions that you are going to get concerning Kubernetes. We are going to see all those possible questions, and we want to start from the beginning, where they will they will ask you, define orchestration. What is the meaning of saying that Kubernetes is an orchestration tool? Can someone try? Can someone tell me, when they say Kubernetes is an orchestration tool, what do we mean? Can someone try that? Everybody is mute.
Yeah, hi sir. Let me.
Sure. Okay.
Go ahead, Declan.
Okay, let me go ahead. I think when they say it is an orchestration tool, it means that it makes all the instances to perform the same duty. The same duty. I think all the nodes and the master node, they are capable of perform the same duty and being accessible at the same time.
Okay. There is one word that as a DevOps engineer you should use. And when you use that word, I mean, you're true. You are trying to explain the details, which is some sort of good. But when you are not using those terminologies, it doesn't go. So when they say Kubernetes is an orchestration tool, what do we mean by that? We simply mean that Kubernetes makes service scalable. It makes service dynamic, right? A Kubernetes service is dynamic and scalable. That is all about orchestration. Orchestration is you are capable of scaling something. Let me take this simple example and you will understand. Let us tell a story. You are a bakery provider. The bakery provider is you here. You are providing bread. That is, you are a bakery provider. This is your bakery. Your bakery is one single computer, right? That's your environment where you are working from. One single computer is your bakery. Good. As this computer is your bakery, you have one person that is working in this bakery and providing bread. You have one person that is working in this bakery and providing bread. You went and built the bakery yourself, and then you trained this one person to start baking bread yourself. Okay? As you train this one person, he starts baking bread, and as he is baking bread, what is he doing? He is providing the bread. All of a sudden, everybody in Bamenda starts asking for bread. All of a sudden, everybody starts asking for bread. As everybody is asking for bread, what happens? This one guy cannot provide more bread anymore. He is going to stop. What do? You think of adding the second guy to be providing bread. You add the second guy to come and start providing bread. The two of them go. There is an increase in production, but this increase in production does not meet this demand. Demand keeps increasing. You discover that no matter how many people that you are adding here, the demand always increases. And what happens? The bakery itself is already getting short. The machines inside the bakery are no more capable of providing. What do? You need to create another bakery. You get it? You need to create another bakery. And what will you start doing again? When you create another bakery, you will start, first of all, training another people to come and work in that bakery again to start providing bread. This is what you are going to be doing again. Now, consider that instead of bakery, this is a computer. This is an EC2 instance. This is a host, right? Instead of people working there, consider these as containers that are carrying your website, your service that you want to be giving to the world. Okay? Instead of bread that they are selling, consider this as the availability of your website to the world. The availability of your website to people outside in the world. Okay? So you see, EC2 or computer equals bakery. The Docker containers equal people that are working there, and the bread that they are producing equals the availability of your website in the world. Cool. So the question is, what gets short? What is always short in supply? In the example of our bakery, what is short in supply is bread. In the example of or in the situation of our EC2, what is short in supply is the availability of your website. As many people are getting access to your website, it is no more highly available. So the bandwidth is short, is small. So you have to create another EC2 to increase this bandwidth, right? And when you create this other EC2 to increase this bandwidth, what will happen? You have to first of all struggle to link these two EC2s together before they start giving these two things in common. Now, how does Kubernetes function and solve this problem? When they say Kubernetes is an orchestration tool that creates auto-scaling and auto-healing, we are saying that Kubernetes now comes, creates an environment in front here where it is going to build one of the one of the bakeries, and then it is going to position that bakery where it is supposed to be, and then also it is going to train one of the workers and also take this worker and send to where the bakery is. Now, just from doing this one thing like this, Kubernetes is capable of multiplying the workers that are here automatically. That means while the workers are here, if there are many bread that is needed, workers are going to be increased. If the bakeries are no more enough, another bakeries are going to be created automatically, and these workers are going to get increased, replicated automatically. That is, Kubernetes is capable of creating as many bakeries as possible that you will need, containing as many workers as possible that you will need. That is the power of orchestration. It creates EC2 instances and creates containers, or in its own case, pods, as many times as possible. That is orchestration. So orchestration is the aspect of creating auto dynamic services that can replicate, scale up and scale down at the same time. How you are going to explain this to the interviewer depends on your personal instincts and capability to bring down technology from the technological aspect into the real world aspect that a dummy can understand. So that is your focus. Step down from technology into where a dummy will be able to Understand? Okay, so that is orchestration. The next thing that we are going to talk about is, okay, if Kubernetes does orchestration, if you happen to be deploying and you are deploying in a server that is already having an application that is running, that is, you are trying to update a legacy system. Or when they talk about legacy system, actually legacy systems mean old model system, old functional system. You know, in the legacy way, we used to build a website. When we build that website somewhere, then we launch the website into an EC2 instance. The website is termed monolithic. That is a legacy system of building things. So with Kubernetes now, you have built this legacy system website. Now you want to update it to microservices. Which type of deployment are you going to use? Which type of deployment method are you going to use to update a legacy system application? Now, there are roughly 4 or 5 types of deployment system. The first type of deployment system is called, we'll take blue-green deployment. Blue-green deployment. This is the first type of the deployment system. Then the second one is canary deployment. Canary deployment. The third one is A by B deployment. A by B deployment. Another one is rolling updates. Rolling updates. Okay. With these various deployments, they are different in one way. Imagine an application is already here. This application is already live. It is running. It is already very, very much live. But they want you to change the application from the old method to the new method. What are you going to do? Now, this is where solution architect comes into place. I hope the client now understands where solution architects will come. Now here, what will you do? You are going to place under blue-green deployment, you are going to place a load balancer here. You are going to place a load balancer here. As you are going to place a load balancer here, you are going to do a deployment in a different server. You are going to do a deployment in this particular server. You are going to deploy now with Kubernetes. You are going to deploy with Kubernetes into this server. You are going to deploy with Kubernetes into this server, right? While this application is running, you are deploying into this server. Okay, this load balancer, what does this load balancer actually does? This load balancer balances the flow of traffic from these two computers. Okay, it balances the flow of traffic. You can say traffic that is coming here is maybe 50%, and you can say traffic that is coming here is 50%, right? But now when you do this, that means this application is already live, which you don't yet want it to be live. So what you do is you make the traffic that is going to the initial application to be 100%. Okay, that means that what all what people are seeing is coming from the old system. Everything people are seeing is coming from the old system. Okay, as it is coming from the old system, what will happen? You deploy the new system now inside this one. When you deploy the new system inside this one, what happens? You then now do a flip. you then do a flip. What is a flip? You change the flow of traffic from here and you bring it here totally at 100%. We are talking about blue green. That is, it is either a blue or a green. You change the traffic from here and flip it to this one at 100%, and then the traffic here becomes at 0. Okay, you put the traffic here at 0. When it happens like this, what will happen? That means every traffic that is leaving now from your system is coming from this new system. When you flip the traffic at 0, you are on standby. At this level, you are on standby. You are ready. If anything goes wrong, as people are using, because people are here, they don't know what is happening behind here. They are simply just consuming everything that they see that is available here. People are consuming things that they are seeing that is available here. So while you are here, you flip the traffic from the old system to the new system, and then you wait whether these people are complaining. If anybody complains that something happened and it went bad, you flip back the traffic to the old system, which is already standard and is very stable, and then you correct whatever is wrong here, and then you flip back the traffic again, and then they start watching. So interviewers always like to ask, what type of deployment are you using? This one is, we have just explained the blue green deployment. It is either or. It is either or. That is a blue green deployment. It is either one server, the old system, or the new system. That is blue green deployment. Now when you come to canary deployment, it is gradual. It is not a matter of either or here. Now here we have, let's consider that we had 100% there. We had 100% here, and then at this particular moment now we have deployed this one. We want to start testing. When we start testing, what we'll do is we'll decrease this one gradually. We can set this one now to 75. When we set this one to 75, we then put this one to 25. Right? We load balance it. That means 25% of everybody that will be getting into our system will be directed here to the new system. 75% will still be directed to the old system. I hope I make myself clear. When I talk of 25, I have to have 75 here. So 25% of the system will be, of the traffic of everybody that is accessing our website will be directed here, and 75% of them will be directed here. We monitor. If this 25% of the people do not complain in any way, we increase from 25% to 50%, and we decrease this one from 75% to 50%. That means the traffic now is flowing to the same, the old one and the new one the same. And gradually we put the 75% now but here and the 25% here, and gradually we cut this one off. That is now canary deployment. Canary deployment. So if somebody asks you to explain your deployment strategies, talk about, choose one in which you people were doing in your company, choose one and explain how it was being done, but say that you are capable of explaining the others. Okay, so we take rolling update. Rolling updates generally is a form of deployment in which Kubernetes does that by default. Kubernetes does that by default. What is rolling update? With rolling update, we do not use a load balancer. This one does not need this load balancer like this. So what we do in rolling update is that there are ports that are serving our application. Those ports are available inside here. We can say that there are 2 ports or 3 ports here that are serving our application. Rolling updates only occurs with microservices. It does not occur from an old service to a new service. No, because for rolling updates to occur, it means the first service that is running is already having ports. Okay, which means it is not a legacy system. It is not an old service system. So for rolling updates to occur, what you simply tell Kubernetes to do is, now your new application is found in the pipeline somewhere here. The new application is found in the pipeline. Here's your pipeline that is running to your system. Now your new application is found in the pipeline that flows into your system. When the new application flows into your system, it commands now these ports to start updating one after the other. That is rolling update, right? Commands you update to the new application. How does the update occurs? The command will clone this port, and then create another port. Right? It first of all clones the port, creates another port, and update it with the new system. When the new system is already ready, it deletes now the old port. And before it does this, it removes all traffic that is coming to this port. All the traffic are pushed to these other ports in these other EC2 instances and this other one. So it removes all the traffic that is coming to this one, clones this port, creates a new one, updates it with a new system, and then deletes this one. And then next, it takes this one, clones it, updates it, and delete the old one. Takes this one, close it, update it, and delete this one. So that is what they call rolling update. It takes it one after the other. That is the rolling update deployment. I believe we have already performed rolling updates in Docker, and we have also performed rolling updates in Kubernetes. So we can know the command to launch rolling updates if we happen to ever meet a situation where we need to update our ports using rolling update. So those are the ways by which you can do an update. You will be asking me, what about A by B deployment? A by B is a system of deployment in which you deploy the two systems, the old one and the new one. If you enter your AWS terminal, you will see a small button that says that if you want the old system, click here. Am I logged in? Look at, there is something that says if you want the old system, click here. Where am I? Okay, cool. All right. Let's see something. Okay, when you log into your system, I see that some of us are already making our system to have some few dollars. So it should be ready. Okay, look at up here, right? New EC2 experience. We are in the new EC2 experience. If you want to go to the old system, you can click here. It will take you to the old AWS system. This is now the old system where you used to create your EC2 experience terminals and everything. Look at how the old system used to be. So here we were creating our systems from this one. So the old system is totally indeed different from the new system. Where are we? Here you toggle in between old and new, which means they put the two systems for you to decide which one to use. So that is the concept of A by B system. Sometimes A by B works this way. They decide and they put some cookies on top of your website to tell you that if you want these services or if you want this advancement of the website, you should click on that. Okay, that is the A by B deployment. It is very important. That is that about our deployment. Any question on deployments before we close deployments? Deployment strategies. Yes, Declan.
So from my own understanding, the old system, the legacy system, does it mean that it is still widely used in the industry?
Yes, companies. So many companies are still dragging behind to adopt new systems. That is why there is high employment in the market. That's why there is huge need for people to get employed in the market to do some of these changes. Because some companies do not have the real talents to migrate from their old systems to the new system. They see everything that is good about the new microservice deployment systems, and they know everything about Docker is nice, they know everything about Kubernetes is nice, but their systems are running on a monolithic platform, sometimes even in private servers where they have built in their on-premises environment. Now they want to move to the internet, to the cloud, and they want to adopt the microservice system. So they first of all want somebody to come and look at their system, the way it is built, and then build or Dockerize the system, build a microservice version of the system, and deploy it in the cloud, and then transfer their system from on-prem to the cloud.
Okay.
So many companies are still using the legacy system, please. So many. And then others are using microservices, but the old versions of it, and they always need to update. So you need to be deploying.
Okay, sir.
Yeah.
So based on the different deployment strategies, which one is highly used?
It depends. That is a good question, because they will ask you, they might ask you in the interview session that why did your company choose the deployment strategy that they chose, right? Sometimes some people always just run away from that type of a question and say my manager decided. But if your manager decided, you should know at least the reason. That it should have been a situation where they sat in a meeting and discussed about it, because the manager will not just be the tupusang of the company. No, it would have been a situation where they sat in a meeting and they say, okay, we are going to do deployment. We are looking for the type of deployment to do, and everybody will give his own opinion, and then they will come to a general conclusion that, okay, we should be using this system of deployment. Actually, like we say, Kubernetes have by default rolling updates. First of all, before choosing the type of deployment that you want to choose, What is your objective? Most objectives of many companies is zero downtime. Zero downtime. Do you know the meaning of zero downtime? Zero downtime means that the person that is using your website should not feel that anything has changed, should not for any 1 minute not see the website in the online. That means if I'm like entering ethiopianairways.com, I should be entering there anytime I want to enter, not because they are doing their update that ethiopianairways.com is no more available online. You see some website we are currently doing maintenance, come back later, or this website is not currently available, check back later. What if I wanted to buy for 2 million euros or $2 million at that particular moment? I'm going to a different one, right? So websites always make sure that they have zero downtime. They are always available. Even during updates, they are available. So in order to have that zero downtime, according to you, after having seen all this explanation, which system do you think you can take?
Rolling updates, sir.
Rolling updates, which is true, because if you take rolling updates and you have your systems are being created, your containers are being created, your pods are being recreated, you discover that they are going to be recreated and other ones are going to be there doing services while the others are already updated. Gradually new ones are taking over. Gradually nobody will ever even know that something is happening online. Okay, nobody will ever understand that anything is happening online. So truly rolling update is good. So but if rolling update is good, what is the disadvantage of rolling update? Why should somebody, if rolling update is that very good, what is the disadvantage of rolling update, and why should somebody think of Canary and the others? Yes.
I think rolling updates cannot do load balancing.
Rolling
Traffic is.
Rolling update cannot do load balancing. When you are talking of rolling updates, you don't more need load balancing anymore, right?
Yeah. That's true.
When you are talking of rolling update, you don't need load balancing, because rolling updates updates port by port, so it does not need a load balancer. It updates port by port. The question is, what is the disadvantage of rolling updates? Rolling updates is very slow. It is really very slow. If you have a new feature and you want it to be online like now, don't even just dare for rolling update. It is really very slow. Okay, rolling update is slow. When you start rolling, if you start rolling updates for a real company website, for it to finish and everybody start getting access to the new features of the website, it is going to really take time. Okay, so that is why people start thinking about, might be Canary is better, might be Blue Green is better. So given the fact that rolling update is slow, what do you think is the best alternative now?
Me is a Canary.
In Canary, what happens there? We gradually give traffic to the old system, to the new system, and we observe, right? When you give traffic to the new system, you observe. You increase the amount of traffic that is flowing to the new system and you observe. That is how you keep doing. Okay, that is Canary. Now, what is the disadvantage of Canary that rolling updates have over Canary? The disadvantage of Canary is that, well, with Canary you need a load balancer, and which means you are going to put all your instances under a load balancer. Okay, and as all your instances are going to be under a load balancer, it is not going to be automatically monitored. You are going to be coming and like tuning the percentages. I want to tune from one percentage to the other. I'm gradually tuning it. Let me increase it now. And you observe, you increase. So it is highly manual. And DevOps is not something that we can be talking about manual things. So that is the issue with Canary. Blue green. Well, for me, blue green, you put all the traffic in the new system and you stand and you are observing. Anything goes bad, flush back all the traffic into the old system and you correct whatever you are correcting, bring back all the traffic into the new system. To me, blue green is fast, very fast, but things can break down, and when things break down, it affects all the whole system, but you can also flush back as early as possible. So blue green also is good. So it depends on your system, and it depends on the way your system is highly available. Is it a system that is highly available and people cannot do without it? You decide which one to take. Okay, so generally, don't go and start boasting that we are working on a very highly available application in Cameroon. They can ask you in Cameroon, what was a highly application doing? Can you think of any application in Cameroon that needs to be that highly available? Can you think of any service in Cameroon that needs to be that highly available, that if it is not there, there is trouble? Can you think of any? You guys are just too small-minded service. Now, without any publicity, please. Momo Cash is an application for MTN transfer services, and it is highly used by call boxers. Momo Cash application. The engineers working behind Momo Cash application cannot afford that application should go offline, because some people are making a life out of that application. If the application is not there, those people are not working. So the Momo Cash application has to always constantly be alive. That means it is highly available. It needs to be highly available. So you can start boasting about those type of applications that you have worked with behind and all those type of things. Yes, Mr. Kiba.
Yes, I was just about to talk about MC, and then you mentioned it.
Yes, that is an application that actually is like a job. The application being available is like a source of income to other people, so it needs to be highly available. So those are the type of applications that you are acting. But when you are talking about simple company websites that people go there to check just for information, and simple websites that are just there to, help you log in and upload some small files, their availability is not that way so important. So we can cut them off from the service from online, and we do some work behind and we put them back. Okay, so it depends on you, and it depends on what your application is doing. Does that answer your question?
Okay, sir.
Good. All right, next we are already off time. We are going to continue these lectures sometime, but I would have really loved that we talk about the various how secrets are passed in Kubernetes. We have to talk about how secrets are passed. We have to talk about namespaces in Kubernetes, because they will always ask you what is a namespace in Kubernetes. They will always ask you what is an ingress in Kubernetes. All these things I'm saying, please research them on your free time. what is a namespace, what does a namespace do in Kubernetes, do the research of that. What is ingress in Kubernetes, research on ingress in Kubernetes and find out how ingress is being used in Kubernetes. Look at RBAC. This is what I want you to look at. This is the word RBAC. Look at RBAC and see what it does in Kubernetes. This is all what I want you guys to look about it. And when you look at do some sort of an expose into what all these things do, and then you are going to do a presentation. Because if you can do a presentation on ingress, if you can do a presentation on RBAC, if you can do a presentation on namespaces, you are already halfway concluded with Kubernetes. All it needs to do now is for you to know how to do cluster auto scaling and pod auto scaling. What do you do? Because they once asked me a question after I've explained all these things very well when I was still just beginning in Kubernetes. I explained auto scaling and how it is done, pod auto scaler, explain how the various different auto scalings are being done, and then they asked me that, okay, what do you do in order to ignite auto scaling in Kubernetes? What do you do in order to do pod auto scaling in Kubernetes? What do you change, or what do you configure, or what do you touch? So try to find out about that. How is auto scaling in Kubernetes achieved? Try to find out about that. It is all about the YAML. Let me give you a heads up. It is all about the YAML. Okay, let's not make our video too long. Any other question before we close? Yes, let Mr. Kiba go first.
Yes, hi. So at the beginning of the class, you made mention that Kubernetes is like it's a tool that's responsible for auto scaling and always highly available.
Yeah.
When we were doing our YAML, we went to replica and we insert some values like 3. We need 3 nodes or 4 nodes or 5.
Yes.
Does it mean Kubernetes can exceed this number? In case we put a replica of 2, it cannot exceed, right, the number of nodes. That just end there.
That was not auto scaling. That was a replication.
Oh, replication, yes, sir.
That was replication, right? Now you have said that their pods should replicate and be 3. Okay. Now you have deployed that YAML. At one moment now, you want that when there is a lot of traffic, those pods should pass from 3 to 9, for example. And when the traffic drops, the pod should pass back from 9 down to 3. That is what we call auto scaling.
Okay.
You get it?
What about replica? Yes.
Auto scaling is actually making the replication occurs automatically without you doing it.
Okay, sir.
Yes. Yes, Declan.
I think it was Renee. I did not read that.
It was Renee. Okay. Where is he? Renee, you had a question.
No, I don't have a question, sir.
All right. With that, I think I've given you a lot of work for the weekend. For the week, please. Nobody should sleep. I've given you work that I wonder whether you can do. So do the research, and I would like to get a presentation from you. I've told you all these things verbally, theoretically. I've not shown you anything. I want you now, because as I keep telling you, DevOps is all about, you can never do anything during the training. You can never do everything. So there will be certain things that you are only going to see them at the job site, and there are certain things that the trainer will never tell you. It is by constant research that you are going to see those things. So do the research that I've told you, and let's see how we can get up from there. Okay, thanks everybody. See you next week.